Hi there! Today we're going to continue our problems from paper. This is AAHL, paper 1, Thursday 6 May 2021. I'm not sure what time zone is this, but let's just continue. Read the questions, pause it if you need it. As you can see, if it's related to trigonometry and you have to change it from sine 2x to just x, it means you need to use the identities. Identities can be found in the paper formula booklets. Let's find it. Trigonometry. There you go. The SL part. Since yours is 2x and you have to change it to x, it means you need to use the identity from double angle. Sine 2 theta equals to 2 sine theta cos theta. We'll need that, so we're going to replace it. Sine x cos x. And then for the cos 2x, you have three options: cos square minus sine square, 2 cos square minus 1, or 1 minus 2 sine square. This might help you to pick which one. If you do rainbow it, if you imagine, not actually doing it, imagine you rainbow, do the multiplication, you'll find 2 sine x cos x minus 2 sine x sine x, or 2 sine square x, right? So use the one with 2 sine square x. I'll replace the cos 2x with 1 minus 2 sine square x. And minus 1, I just copy it, okay? If you see it here, 1 and minus 1 can be cancelled. Both has 2, I'll remove the 2. Not remove, factorize the 2. There's sine and sine here, I'll factorize the sine x as well. And for the rest, I'll just need to copy it. Cos x minus sine x. And voila, proven. For part B, if there's a word hence on it, it means you need to use your previous answer from part A to help you in order to find solution from part B. Blah 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 blah. If you do notice, the problem here is the same as your problem before. So I'll use the previous answer to replace this part. Okay? So 2 sine x bracket cos x minus sine x as its replacement, and I'll just copy the rest, plus cos x minus sine x equals to 0. Maybe you didn't notice about it. If you put bracket here, both will be the same. Cos x minus sine x, cos x minus sine x. It means you are allowed to factorize it to make it more simpler. So I'll factorize it. Cos x minus sine x. Okay? And I'll copy the rest. That will be 2 sine x plus, please to remember, when you remove all of everything as a factor, it doesn't mean that the remainder, the thing that you need to write will be 0. It doesn't mean like that. It's supposed to be 1. So it's a 1 here. Okay? Equals to 0. So it means the first bracket will be 0. Or could be the second bracket that is equals to 0. Okay, doing algebra, sine x, I'll move the sine x to the right. the goal is to make them as a one term, as a same term. Cos x and sin x are different terms, so it will be difficult to find the x. And if you notice here, there's an identity of tangent, so divide it all by cos x. 1 equals to sin x over cos x, which is equals to tan of x. Okay, if you do remember, x will be pi over 4 from the first quadrant here, and also it might be from the third quadrant. For the second one, that will be pi plus angle. If your first angle is pi over 4, then this will be pi plus pi over 4. 5 pi over 4. And for the second one, same, simple algebra. 2 sin x equals to -1. I'll move the 2. Sin x will be -1 over 2. If you do remember about trigonometry angles, -1 over 2 belong to the third and fourth quadrant. For the first quadrant, it will have positive result for sine. It will be pi over 6 at the first quadrant. But since it's negative, it means the angle will belongs to the third and fourth quadrant. For the third quadrant, it will be pi plus alpha, pi plus your angle, 7 pi over 6 then. And for the fourth quadrant, that will be 2 pi minus angle, 11 pi over 6. So my x looks like an alpha. I'll fix it. This is an x, this is an x. Okay, so for the second part, x might be 7 pi over 6 or 11 pi over 6. So your answers for solving the x are 4 of them. Pi over 4, it's supposed to be pi over 6 first. Pi over 4, 7 pi over 6, 5 pi over 4, and 11 pi over 6. 1, 2, 3, 4. Why I wrote it so much? Oh, wait a minute. Oh, this is not included. Scratch that. Only on the third and fourth. First quadrant is not allowed since the first quadrant will have positive values for all trigonometry ratio. Next number 6. It's not difficult, I guess. Yeah. For HL student, there you go. You are an HL student. So there's another Pythagorean identities that you need to rely on that includes cosec and cotangent on it. That will be the very last one here. 1 plus cotan square equals to cosec square. So they ask for cotan. Oopsies. They ask for cotan here. So use that identity. 1 plus cotan square angle equals to cosec square angle. If you want to find the cotan, then you move the one to the right. Cot square theta equals to cosec square theta minus 1. And you need to move the square. It becomes the root. Here's the problem. Every time you do the rooting stuff, you need to add plus or minus. Okay, which one that you need to use? Is it both positive and negative? No. Since they give you the exact positions of the angle, it lies between pi over 2, which is 90 degree. Here you go, pi over 2, and 3 pi over 2. 3 pi over 2 means down here. So the regions are either or maybe both on second or third quadrant. But since the cosec is positive, cosec is the reciprocal of sine x. The reciprocal of sine x will be your cosec. The positions where the sign is positive is in the first or the second part of the quadrant. Okay, but since the domain given here only lies in second to third quadrant, so your positions is in the second quadrant. Okay, and cosec x is the reciprocal of second. Oh, scratch that, sorry. Cotan. Cotan is the reciprocal of tan. When it's on the second quadrant, the value of cotan will be minus. So from these two options, please pick the negative sign. Minus cosec square, which is 3 over 2, minus 1. And we're done. Okay, we'll do number 7 next meeting. I'll see you soon. Bye bye.